Okay, so let's get started off with giving a quick introduction about myself. This is me, Faizal Khan. I'm currently founder and CEO at two organizations, Ecom India Cloud IT as well as ExciteLogic. Ecom India Cloud IT is based in Hyderabad, India. ExciteLogic based in the US. Both are born on the cloud companies, and we're building products that'll help people both move on to the AWS cloud as well as other services, SaaS services on AWS cloud. As far as AWS itself is concerned, my contribution on the side of AWS is that I am also a user group leader in Hyderabad, which is basically a community of people who talk about AWS, who want to learn AWS. And I would actually encourage you to join the community, the user group in any of the city that you're currently coming from, that you're currently in. On the certification front, I'm a solutions architect professional certified. I've also been an AWS community builder for a couple of years. And then I kind of graduated, you could say, to the AWS Community Heroes program. What do I do in my free time? I have a couple of things that I do. First of all, I have some training that I do for AWS under the EICIT learning channel. And I recently started a new brand called Racer Parrot, which is basically something to do with Formula One. So if you guys know Formula One, there are these radio messages that the drivers actually call out, right? So I kind of take those messages and design t-shirts around that and other merchandise. So do check it out if you need to. And I recently built out a community forum called Let's Talk AWS. It's where you can go and ask questions about AWS, or talk about what you're doing, even share your knowledge if you wish to. Okay, with that out of the way, let's look at what we're going to cover today. So let's just quickly look at some of the basic concepts of domain names, and then we'll talk about DNS routing, and we'll talk about some of the common DNS record types that you have, and then we'll talk about Route 53 itself, and we'll talk about the different routing policies that you have within Route 53, some of the traffic policies, and something known as a Route 53 resolver, and then I should be able to show you some labs quickly. Okay, some of the domain name basics here. There are different levels when you talk about domain names. So there is something called top level domains. These are your .coms, your .nets, and your .orgs, right? So like the last bit of your domain names. These are known as TLDs, or top level domains. Then you have something called the naked domain, which is basically the name plus the TLD. Okay, so this is the name plus your TLD, which kind of is basically your naked domain. There is a reason it's called a naked domain, which I'll explain in a second. And then you have something called a subdomain, which is your naked domain plus something in front of it. Okay. Now, you might have so far thought, I mean, if you know this, well and good, but so far you'll be forgiven to think that these are the same. They aren't. These are actually completely two different domains. So I can have a completely different site on example.com, and I can have a completely different site on www.example.com. These are completely two different domains. Okay, because one is a subdomain and one is a naked domain. But to make things convenient, whenever someone creates a website, they actually redirect www.example.com to example.com. So even if you type example.com, or even if you type www.example.com, you're kind of redirected to one, and you're only using that one. But ideally, if you choose to, you can have a complete different website on example.com and a completely different website on www.example.com. They aren't the same thing. Just keep that in mind. Now, a subdomain can also be like mail.example.com or app.example.com. All of these are subdomains, right? Because they are sub of the main naked domain. You can also call it as a fully qualified domain name in some cases, but ideally speaking, a fully qualified domain name, or an FQDN, okay, FQDN, a fully qualified domain name, is something where you are describing that in as much detail as possible. All right. For example, server 1 refers to the server, like US-east refers to where it is. dot prod refers whether it's dot prod or test, and then finally you have the naked domain. So this is kind of like defining the domain as much as possible so that you can have multiple combinations of it. This is what you would call a fully qualified domain name or an FQDN. So keep these things in mind because we'll need it in the future slides. So before I go into how DNS works, let's just look at a basic flow of DNS. So there is something called the resolver, the root DNS, the TLD DNS, and the authoritative DNS. And the flow is always like this. The resolver will ask the root DNS, the root DNS will pass that information to the TLD DNS, and the TLD DNS will pass that information to the authority DNS, which will then finally pass the information back to the resolver. Okay, this is the flow, but I'll show you how this flow happens. Okay. Yeah, Harish has a question. Could you please show a small demo for naked domain and subdomain? So far, I have used both. Seems same. That is exactly the point. I will show it to you today. Hopefully within the next 15 minutes if we have the time, but I should be able to show it to you. No problems. Okay. The resolver is the one that actually does the resolving. So what is DNS per se? DNS is domain name system, where basically you have a name being resolved to an IP. Okay. The reason is simple. As humans, we are not good at remembering numbers because IP address, I mean, of course, there are geniuses who can remember big numbers, but not all of us are geniuses. So we have issues remembering numbers, and some of us are not good at maths. So we're not good at remembering numbers. Okay. But we are good, kind of better, at least in remembering names. So it's easier for us to remember like google.com instead of remembering the IP address of google.com, right? I think there was a time when we used to all remember our phone numbers of our family and everyone, but today we have it as contacts in our phone books. So yeah, same thing. So DNS allows you to convert a name to an IP address, because as humans, we are good at remembering names, but computers still use the concept of IP addresses. They need to know they need to know the IP address in order to fetch something. Okay. So DNS allows that translation to happen between name to IP. So a resolver is the one that actually starts that process. So the resolver goes and finds out what is the IP. That's the job of the resolver. Okay. The root DNS is a set of servers. I believe it's a set of 13 clustered servers, which has information about all of the TLD servers. Okay. So the TLD servers are what? The .coms, the .nets, etc. So these are managed by certain organizations. For example, .com, I believe, is managed by VeriSign. VeriSign, I think it's managed by VeriSign, where they take care of the complete .com TLDs, right? So the root DNS has information about the servers about .com, the servers about .net, etc. Right? It doesn't have all of the information about the domain names itself, but it has information about the servers that are handling the TLDs. Okay, and the TLDs have the information about the servers that are handling the naked domains. For example, example.com. Okay, this is a naked domain. So the TLD DNSs for those particular TLDs has information about the servers that are handling each and every naked domain belonging to that TLD. Let me show you the diagram. It will become a little bit more clear. So as an example over here, we have a user who's trying to go to www.example.com. So there is the web server which he needs to access. The web server's IP address is 102.15.2.91, and this is the web address. Okay, so in order to fetch this page, www.example.com, the user needs, oops, what happened there? Yeah, so in order for the user to load the web page on the computer, this computer needs to go ahead and find out this IP address. Once it finds out the IP address, it will make a direct connection and then load the web page. That's the whole idea, right? So over here, you have the web server, and then you have something called the authoritative DNS or name server. This name server or the authoritative DNS is the one that holds the information about the naked domain. So the naked domain here is example.com. It holds the information about all of the subdomains of the naked domain. So for example, here www.example.com, mail.example.com, db.example.com. This authoritative DNS knows the IP address of each of this. Okay, it knows the IP address of each of this because it's in the same network, or it's kind of associated. So the authority DNS knows the IP address of www.example.com is this. That information is with the authority DNS. So ideally speaking, this computer needs to ask the authority DNS the IP address for this in order to get this IP and then make a direct connection. But it is not that simple because there are other servers that are involved in the process, which is the root DNS, the TLD DNS, and the resolving DNS. Your resolving DNS is normally your internet service provider when you have your connection set up for the first time. Your internet service provider will kind of configure the resolving DNS on your connection, on your router, and whenever your system wants to find out something, it will go ask the resolving DNS, and then it will start from there. Let's see a flow, how this happens. So the user wants to find out the IP address of www.example.com. Let's assume that this is the first time they're doing it, because if they've already done it, normally the IP is stored in the cache of the system. But let's just assume that this is the first time that they're doing it. So the first step is the system will ask the resolving DNS, can you find out the IP of www.example.com for me? The resolving DNS will then first ask the root DNS, hey root DNS, can you tell me the IP address of www.example.com? Remember, the root DNS does not have information about that subdomain or that naked domain, but it does have information about the TLD servers that is handling .com. So what it will do is it will tell the resolving DNS, I don't know the exact IP address of www.example.com, but I know the IP address of the .com servers. So here is the IP address. Go ahead and ask the .com server. Okay. So the resolving DNS will get the IP address of the .com TLD. It will then ask the .com TLD, hey, can you give me the IP address of www.example.com? Here again, the TLD does not have the information about the subdomain, but it has information about the naked domain, as in it knows the server that is handling the naked domain. So it will reply back saying, I don't know the exact IP address of www.example.com, but I know the server that is handling example.com. Here is the IP. Go ahead and ask it. Okay, so that IP will be returned, which is basically the IP of the name server or the authority DNS. And finally, the resolving DNS will ask the same question. Hey, can you give me the IP address of www.example.com? And obviously, this time the authority DNS does have that IP because it has the information about that subdomain, and it will return back that IP, which is 192.15.2.9. And it will return then that IP to the system, which then, once the system gets the IP, it will then establish the connection to the server. All of this process, whenever you type a website address, happens just like that. At the split second, all of this is actually happening in the background when you search for a domain name. Okay, so keep this in mind. If DNS system does not exist, your internet is not going to work. Okay, so this is a very core function of DNS for the internet to survive. And you're not always directly connecting. There's all these queries that are happening. However, in order to save this process from happening again and again and again every single time, once you get the IP address, you tend to store that IP in the cache of the local system. Okay, so that every time it does not have to ask this question that you need to ask you need the IP, because the next time you need to access this, it will go ahead and just directly connect to the IP. Okay, can someone tell me which part of this do you think is Route 53? Where is Route 53 here? Which is the system Route 53 here? Is it the resolving DNS? Is it the root DNS? Is it the TLD? Is it the authority DNS? Which part is Route 53 here? Do you think? Nobody? Anybody? Which part do you think is the Route 53 over here? This is your Route 53. Okay. Basically, you are going to add your domain to Route 53, and this is your EC2 instance. Okay. So you're going to add your domain in Route 53, and all of the records will be created inside Route 53. So all of the records for www.example.com, mail.example.com, db.example.com, etc. will be created inside your Route 53, which will act as the authoritative DNS for your domain. What that basically means is once you add your domain to Route 53, if anybody wants to find out the IP address of your domain, the end request will have to come to Route 53, and Route 53 will answer, giving back the IP address. So that's the job of Route 53. Route 53's job is to answer queries on your behalf for your domain name, and then it will always return the IP address of wherever you have hosted that domain. Okay. Now, remember I told you about the cache over here. It is also important to specify that cache when you create the record. So for example, if you create a record for www.example.com inside Route 53, you have to specify that cache, and this is where that cache concept of TTL or time to live comes in. Okay. So if you specify a TTL of 30 minutes, that basically means this IP address will remain in the user's cache only for 30 minutes. After 30 minutes, that cache will expire. So if the user needs to again go to that website after 30 minutes, he needs to again go through this whole process again in order to get that IP. Okay. If you say a TTL of 1 minute, then obviously the cache will expire after 1 minute. You have to decide between how long you want to keep your TTL and how short you want to keep your TTL. Because if you keep your TTL too short, let's say you kept your TTL only 1 minute. Okay. This means anybody accessing your domain will have to again and again after every minute, they'll have to come ask the question to Route 53. And Route 53 charges you based on how many queries it's answering. Okay. So if it answers 100 queries, you pay less. If it answers 10,000 queries, you pay more. So if you keep it too low, then you're answering more queries from Route 53. However, you don't want to keep it too long as well. For example, if you keep, let's say, a TTL of 1 day, okay, everybody will have this IP stored on their system for 1 day. But what if something happens to your server and you had to change the IP, and now www.example.com goes to 92 instead of 91? What happens then? When people try to access it, they will try to go to 91 because their TTL is still 1 day and the website won't load. All right. So you have to kind of balance this between, how quickly you want to refresh the cache versus how long you want to let the cache be there. So that's up to you. A couple of important things to just keep in mind. A record is basically IP of a domain name. Okay. So if you have like example.com, the A record for that will basically be pointing to an IP address like 52.16.9.3 or something like that. Okay. It'll just be pointing to an IP. NS record is basically the IP address of the name servers. So every domain will have an associated DNS or a name server. So every domain name will have a name server IP that is associated with it. This is so that they can find out which name server to get to. The CNAME or alias record. So this is where one domain name points to another domain name. This is the example where I wanted to tell you about the www.example.com pointing to example.com. So this is where you normally create a CNAME record, and you say that anybody typing in example.com, it's a CNAME of example.com, which means it's basically one domain redirecting to another domain. That's essentially what a CNAME is. I mean, there is more to it, but that's essentially what a CNAME is. Then you have MX records if you have mail servers. Then you have something called SOA records or start of authority. This will always be there by default. This is basically establishing like who's the authority for your particular DNS. Then you have something called TXT records. You use this if you want to do additional validation. For example, if you want to verify that you are the owner of the domain, you will get some TXT records that you have to create within your DNS so that they can confirm that you are the owner of that particular domain. All right. Route 53 itself is going to act as the authoritative DNS for your domain name. So it will answer queries on behalf of your domain name. So you will add your domain name in Route 53, and you will add the records for Route 53 inside that. There are different types of routing that are available. There is something called latency-based routing or LBR. There is geolocation-based routing. It also integrates with other AWS services. And of course, if you want, you can register a domain name. So let's talk about the different routing policies. Let's start with a simple routing policy. So in Route 53, a simple routing policy is essentially you are creating something called an A record. You are having a domain name that you're routing to an IP address. In our example over here, I have a load balancer which has some EC2 instances behind it. Now, normally you would actually have a domain name that is associated with your load balancer, but let's take an example over here and let's just assume that this load balancer has an IP address. Okay. So we want to send anybody looking for www.example.com, we want to send them to this IP address. That's our goal. So what we will do is in Route 53, we'll create this record in Route 53. And when someone queries for the domain name, it will pass through all of those steps that I just showed you in the previous screen. And then it will finally hit Route 53 and it'll ask for the IP address of www.example.com. And Route 53 will say, here is the IP address, go ahead and connect to this. And then the user will make the connection to that IP address. Remember, Route 53 does not route the traffic. Keep that in mind. Okay, it does not route the traffic through Route 53. It only responds and gives the IP back to the user. The user then has to make a connection separately to that IP address. Okay, just keep that in mind. So it's not a routing traffic like ELB or anything like that. So that's a simple routing policy. Then you have something called latency-based routing policy. This is if you have multiple environments and then you have to, you can basically route users based on their latency between their location and the nearest region. So for example, over here, there are 3 regions that I'm using: North Virginia, Oregon, and North California. And I have the same content in all of the regions, right? I don't want to have different content because I don't want to have different users going to different content. I want to have the same content across all of them. So I have a website running the same content across all of the 3 regions. I will set up latency-based routing. And what happens is Route 53, because it's a highly available and highly scaled system, it knows the latency between the user's location and all of the different regions. So it knows the user's latency between North Virginia and the user is 20 milliseconds. The latency between Oregon and the user is 35 milliseconds. And the latency between North California and the user is 42 milliseconds. So what do you think is going to happen here? Which IP do you think Route 53 will return? Route 53 will return the lowest latency routing in this case, which means it will return the North Virginia IP. So it will return back to the user go to IP 10.65.2.6. Now, this might not always be the same. The next time if the user queries, if this is, for example, 18 milliseconds or something like that, then the next time he will get this IP instead of the other one, right? So this is what it is. You can always get the user to connect to the quickest region that is next to him. Okay, this is assuming that you have something set up there. Okay, it's not just going to directly just give that. You have to have something set up. Then you have weighted routing policy. This works in a similar fashion, but this does not look at where the user is. Rather, this looks at trying to balance your environment in some way. Okay, so let's assume that you have set up a weightage of 25% goes to North Virginia, 15% goes to Oregon, and 16% goes to California. Remember here, this is not traffic percentage. You're not doing load balancing. Okay, you are just saying that if somebody queries, the number of queries that is coming in, you respond back in this percentage. Okay, I'm telling Route 53 to do that. So when people query, for example, www.example.com, 25% of the time they will get this IP, 15% of the times they will get this IP, 60% of the times they will get this IP. Now, even if I made this 33, 33, and 33, it's still not load balanced. Maybe the first time it's load balanced, but then after that it is not balanced because, okay, stay with me for one quick minute here. I'm going to try to explain this to you. If 100 users come in at 10 a.m. and requested for the site IP, 33 of them will get this one, 33 of them will get this one, and let's say 34 here. Okay, 34 of them will get this one. Okay. Maybe at 11 a.m., out of this 100, 50 people returned. Okay. At 11 a.m., 50 people returned. Now, do I know which 50 people those are? It might be 33 from here and 20 from here, right? I don't know. Like you can't control that. Once the user gets the IP, you can't control how many people come back to that same environment. So this is not load balancing. Okay. But when you're, I mean, it does it on some level, but this, you don't do the load balancing over here. You use something else, which we will discuss in our next session, how you actually do global load balancing um, using other services. But you do this again if you only have the same content. You don't want to do this if you have different content. And then you have something called geolocation routing policy. The way I would describe this is, think of it like YouTube, where if you go to youtube.com, depending on which country you're opening it from, you will see different content, right? So if you're opening it from the US, you will kind of see US related content. If you're opening it from India, you will see India related content. This is because you are being redirected to an environment that you are supposed to go to. Okay. This is where I'm hard coding, saying that if anybody is coming from US, always return them the IP address of North Virginia. Okay. If anybody is coming from the European Union region, always return them the IP address of London. If anybody is coming from the Asia region, always return the IP address of Mumbai. So this way, I'm controlling from which region people are coming and which region I need to redirect them to. This way, I can have different content in each of these environments that are specifically suited for that particular country or for that particular region, so that they see only that content. This is essentially what geolocation routing is, and I'll definitely show you this in action. And then the final one is failover routing policy. Failover routing policy is where you have something called an active, which is primary, and then you have a standby, which is secondary. Okay. Your Route 53 will always return the primary, always return the IP address of primary. So whenever someone queries for it, it will always return the IP address of primary, unless and of course something happens to the primary, then it will stop returning the IP address of primary and it will start returning the IP address of your secondary. So it's up to you whether you want to completely keep an environment running in secondary always, or maybe you just want to have like a static web page on S3 which says that we are currently experiencing some difficulty, please come back later, or something like that, right? It's completely up to you. But the idea here is that you will have a primary and you will have a secondary, and there will be a health check that you're running. And if primary fails for some reason, then it will start giving the IP address of the secondary. Till that time, it will always give only primary. Harish has a question. Does GPS takes place part in geolocation routing policy? So not really GPS. What happens is there is globally a list of IPs that belong to certain regions, right? So for example, when you're logging in from India, regardless of your GPS location, you are connecting with some data provider, right? If you're using a SIM, you're obviously using a cellular data provider. If you're at home, you're using some broadband provider. All of these providers have a block of IP addresses, and those IP addresses belong to a certain region, right? So based on that IP location, they will kind of decide where you're coming from. So if you're coming from a IP block that belongs to, like, say, India, then you will be identified as someone coming from India, which is why when you go to certain websites, it tells you that this content is not available in your region. That's basically that. They look at your IP and then decide which region you're coming from. Okay, now we talked about all of these different routing policies, right? Simple routing policy, latency-based routing policy, weighted routing policy, geolocation policy, failover policy. You actually have the choice of either using these policies individually, or you can also kind of chain them, okay, using something called traffic policy. So over here, as an example, I can start off with a failover routing policy. I can have a primary and a failover, okay? So in that failover routing policy, under primary, I can have weighted. So within primary itself, I can have a weighted routing policy where they go to two separate endpoints so that the traffic is kind of balanced, I would say. But if for some reason this entire primary fails, then I can switch over to the failover and it can go to endpoint. So I can in fact kind of chain multiple policies together in order to create something called a traffic policy. Okay, any questions on this before I go and show you the labs? So in Route 53, there is something called hosted zones. This is where basically you add your domain into Route 53. There is a question about the cost. So in Route 53, you can choose to either register your domain in Route 53, which will cost you depending on the extension. For example, I think a .com domain costs you around $13 or something like that, right? But it's not necessary for you to register your domain with Route 53 in order to use Route 53. You can register your domain someplace else like GoDaddy, or in fact you can use our service, which is outpowerhosting.com, and you can register your domain there. But once you register your domain, you need to still add that domain into Route 53. You do that under hosted zones. So regardless of whether you bought the domain from Route 53 or not, you still have to add your domain under hosted zones. So you just create a hosted zone, type in your domain name over here, and it will mostly be public. Private is if you want to use DNS only within your VPC. Okay, but this time we are just using public. So type in your naked domain here, and you can just create a hosted zone. When you do that, you will see your domain over here. For example, I have this domain here, aws-training.in, which is a naked domain that I've created over here. Okay, so I've added this naked domain into Route 53, and as you can see, I already have some records in Route 53. Normally, when you create or add the domain into Route 53, you will see two records that are created, and those are these two records: the NS record and the SOA record. Remember, I told you SOA is like start of authority. This will always be there by default. Don't delete this. And NS is basically the name servers. So it's basically Route 53 is telling the whole world that if you have any questions about aws-training.in, the name servers that are responsible for answering that question are these four name servers. Okay, so all of the queries about aws-training.in will hit these four name servers, and these four name servers will make use of all of these records that I've entered here in order to answer the question. Okay, so once you add your domain name into Route 53, you need to make sure that your domain's name server matches these four records. And once you do that, you can then go ahead and start creating records. So let's do that. Let's first start off, and let me quickly create. Yeah, let me quickly launch maybe one or two instances, and I'll just show you. I'm just going to put a couple of simple websites on. Just give me one quick second. So I'm creating an EC2 instance which has a website on it, and in fact, I'm just creating quickly a couple of instances which I can show you how the routing works. Just give me 2 minutes. Okay, so I have about 3 websites and we should be good. Let me. Okay, as an example, I have an EC2. Okay, I have an EC2 with a public IP address inside which I have basically installed this website. Okay, this website is called editorial. And right now, as you can see, I'm opening up this website with IP address, right? But I don't want to use IP address. I want to use a name because I can't give this IP address to everyone else. It's hard for them to remember it. So I need to use DNS. So what I'll do is I'll take this IP address, which I will need, and I'll go to Route 53 and I will say create record. Okay. Now, like I said, you have multiple routing policies, simple routing policy, weighted, geolocation, etc. So let me first create a simple routing policy and show you how this works. So I'll select simple routing policy. I will keep a low TTL of 1 minute because I'm just doing it now for temporary use. And let's say I am creating this site called site.awstraining.in, and I will put in this IP address over here as a value, and it's an A record. And A record basically means name to IP. Okay, so the website is basically site.aws-training.in, and the value, the IP address is this. It's a simple routing policy, and TTL is 60 seconds, and I'm creating the record. So as you can see here, this is the record that's got created, simple record for site.aws-training.in that goes to that IP address. Now, if I take this name and if I put this here and hit enter, as you can see, it works. In fact, you can try going to this website right now and see if it works. Go to site.aws-training.in. Site, site.aws-training.in. You can go to the site and you can see it works. So essentially, I got a website up and running in under 5 minutes with the use of EC2 instances with some quick code in it, along with DNS. So it barely took me 5 minutes to put up a website. Does it work for anyone? I do want to mention that if you do add your domain into Route 53, there is a cost of 50 cents per domain name per month. So that's half a dollar per domain name per month. Okay, so just keep that in mind. It's not much of a charge, but it's still a charge. So keep that in mind. Did the website open up for anyone else? Okay, so that is a simple routing policy. So I have one server handling one IP. Okay, that is one routing policy. So let me just go ahead and create the other routing policies that I mentioned. So for example, I will create a weighted routing policy, and you guys need to actually play along with this because I will create something called W1, and I will actually use this website, which is the other two servers. One is called 40 and one is called Massively. So I have two other websites that I want to show you. One is called Massively and one is called 40. So I'll use these IP addresses to create. So I'll again, I will basically create a weighted routing policy. And I will say this. And because this is 0 to 255, I will say a weighted routing policy of 126 or 127. And then I will add another record and I will do the same thing, W1. So it's the same record that I'm creating, w1.aws-training.in and w1.aws-training.in. But I'm sending this to two different IP addresses. Let me just show you that. As you can see here, the two values are different, right? The two values are different. And I'm using weighted routing policy for both of them. And the values are split 127 each. Okay, but both of them are going to w1.aws-training.in. And if I make this to 1 minute, make this also to 1 minute, create the records. Okay, I just need to give it a name. So I think this belongs to massively. So I'm just going to call this massively, and I'm going to call this 40. So just a name for identification. Create records. As you can see, I have created a weighted routing policy for the same domain, w1.aws-training.in. So I want you to go to this site quickly and tell me what site are you getting. So if I go to w1.aws-training.in, I'm getting 40. Please tell me what sites are you getting. Whoever is trying it, quickly, please. Anybody getting the massively website? Because ideally it's supposed to be 50-50, but like I said, it's not exactly a load balancer. You're not going to get exactly the correct split, but okay, so someone else got massively. Anybody else who tried it? Dora Chowdhury got massively. Harish and Mohammed, are you still on? If you can just quickly tell me what you got. Mohammed also got massively. But as you can see, I got 40. Now, if I refresh this, I get massively because my TTL was 60 seconds, right? So the cache got cleared and now I'm getting massively, right? After 1 minute, if I try this, I will again get something else. So that's basically the weighted routing policy. Similarly, you can create your geolocation routing policy, latency routing policy. I mean, I can't really demonstrate this to you right now because we are all in the same region. If there were people from different regions, we could actually test this out. Especially with latency, it's just a matter of, depending on where you are, it'll give you a site. So I can't really say what site you're going to get. But just to show you what it would look like if you were to configure geolocation. So if I were to configure geolocation, I will get the option which says which location do you want to send. So I have multiple options here. I can say continent wise. So Africa, Antarctica, Asia, Europe, North America, Oceania, and South America. So I can send entire continents to a particular IP address, or I can send it country wise, right? So if I say, for example, India, if I say everyone from India should only go to, if I say everyone from India should only go to massively site, then they will only get massively site. They will not get any of the other ones, regardless of how many times you refresh, regardless of how many times your cache expires, because I am hard coding here saying that anyone coming from India will be routed to this IP address. Similarly, I can do it for other countries as well. The only thing that you need to remember additionally over here is that if you do select United States, in US, you actually get to send them state-wise. So if you are selecting US, you can actually redirect people based on states within US. So you can send people from certain states to certain environments and certain other people from certain states to different environments. So you could do that if you wish to. Okay. How is this going to be different when you have not IP addresses, but for example, if you had a load balancer, right? If you had a load balancer, instead of selecting an IP address over here, you would actually select alias. So you would turn on alias and you would choose an endpoint and you would say something like your application load balancer, right? And then you would choose your region where your application load balancer is, for example, Mumbai. And then if your load balancer is there created, it will show up on the list. But right now I don't have a load balancer created. That's why it's obviously not showing up in the list. But it's the same idea. Instead of an IP address, you're going to use the load balancer. So whatever instances are behind your load balancer, that will load up. Now, the last thing I want to show you here is running a website off of S3. So if you go to your S3 buckets, you can actually have websites running off of S3 as long as your bucket name matches the domain name. For example, you see over here, I have a bucket name www.aws-training.in. Okay. If you go in there, it's basically some static web files. So I have that bucket name there. And if I go into create a record, I can say, for example, www. It has to match the bucket name. Okay, this is important if you're doing if you're sending websites to S3. So www.aws-training.in, and here obviously I will select alias because it's an S3 bucket. So I'll select alias, and I will select S3 website endpoint, and I will select. Okay, where is that bucket? This bucket is in Mumbai. I'll select Mumbai. And okay, the reason it's not showing up here is because I have already created this record, but essentially it will just show up that bucket name over here, and you just need to select that bucket name. Let me show you that record that's already created. Here is that record. Okay, I've sent this to CloudFront. Let me see, I've created somewhere else. Let me see, www. Why is it not retrieving? Cannot retrieve. Okay, I think that is because. Oh yeah, I've already created the www record, right? So obviously it's not going to like allow me to create another one because it's a simple record. If I had created it under weighted, or if I had created it under geolocation or something like that, then I can create multiple records of the same name. But because it's a simple record, it's not going to let me do that. But let me see. I think I have another bucket I can show you. Yeah, so there is this site.aws-training.in. Yeah, I think I can show you that. Let me actually edit this record. So I'm editing this site.aws-training.in. I will select alias. I will select S3 web endpoint. That bucket is in North Virginia. No, that bucket is in Mumbai. Okay, and I will select Mumbai. Okay, there you go. So I have a bucket called site.aws-training.in. So I selected endpoint, I selected bucket name, simple routing policy, and save. Now, because I actually overwrote a record, remember this was already created. This was the first one I just created when we started our labs. So obviously this is already cached in memory. So it might not directly open up the bucket, but let's see. So it's still opening the cached information, right? So remember, this is why TTL matters. If you're constantly changing your environment, if you keep your TTL too high, then obviously people are going to get the old one, right? So let me see. I think, yeah, there you go. So the TTL was just a 1 minute TTL, right? So there you go. This is actually the site loading from S3, right? So this site is basically a static website loading from the S3 bucket. Now, I think I need to go back and answer that question of, can you show the website running with www and aws-training.in, right? So let me show you that. www.aws-training.in. This actually goes to another AWS bucket through a CloudFront distribution. Okay. So here is a site, www.aws-training.in. And okay, I've actually set up a redirect. Hold on. So aws-training.in. Yeah. Let me do one thing. Let me edit this. Edit record. So you see here, I had actually already selected redirect. So that gets redirected to this, right? This is the reason that it's actually going back to the www site, right? But if I want, I can just host a static website over here, and I can say index.html. I can save this. And I go back to the bucket. I can upload. Give me a second. Why is all of them failed? Okay, so this is www.aws-training.in, and then if I just take, my browser might still redirect because it probably still has cache, but let's see. Okay, there you go. So I hope this answers your question that I can have completely different websites. Let me just refresh this to confirm. So you can see I can have completely different websites on www.aws-training.in and aws-training.in, right? So this is what I meant by saying that they are completely different domains. Of course, for convenience, I can have it redirected some back to the same domain in order to avoid confusion, because I don't want people to go to two different websites when they type the two different domains. I just want to make sure they're in the same one, right? So any questions? All right, I think we have taken up too much time today, so I'm going to stop here for the day. And hopefully, once we come back next week in our next session, we can actually go ahead and do the remainder, which is CloudFront as well as Global Accelerator. If anybody has any questions, please do post it in the chat. And for those of you who are watching this after the live session, if you're watching the recording, please do post any questions that you have within the comment section, and we'll definitely try to answer it. And if you're unable to do that, you can always come to our Discord session and post it there. So with that, I'd like to thank everyone for listening in, and let me hand it back over to Sanchit.